Hi, it's Mr. McHugh here. We're going to try to attempt two answers today to these essential questions in this video. How do you identify the slope and the y-intercept of a line by looking at the equation? We'll do a few examples of those. And then how do you graph the equation using the slope and the y-intercept? So two questions, one leads into the other. Let's start with, how do you find the slope and y-intercept of a line when you're looking at the equation? We're going to assume the equation is given to us in what looks like y equals mx plus b form. In other words, the y is by itself on the left side of the equation. The x may have a number or a coefficient in the front of it, and then a number added or subtracted after it. This m, the coefficient of x, this is your slope. A lot of times we like slope to be in fraction form, so if it's a whole number we can put it over 1, but that's going to be the slope of the line based right off of the equation. And then the number that's being added or subtracted to the x, this is our y-intercept. It's going to be the point on the y-axis where our line crosses the graph. So if we can have the equation written in y equals mx plus b form, we've got the slope and we've got the y-intercept simply by looking at the equation. So here are two examples. We're just going to look and find the slope and the y-intercept. So for equation A, if we look at, this is written in y equals mx plus b form, conveniently. The slope, which we call m, is simply 3, the number 3. Or like I said, since we like slope as a fraction, you might write 3 over 1. So that's the slope. The y-intercept is simply 4. And we use b for the y-intercept. That's the way that we identify the equation, y equals mx plus b form. So y equals 3x plus 4. The y-intercept is 4. And the slope, this is the slope here, m equals 3. Now in the second example, here's our slope, which we call m, and it's negative 1/3. It already is a fraction, so no need to make it a fraction. And then the y-intercept, here it is. The y-intercept b is a positive 8. Now in both of these examples, the y-intercepts were plus 4 and plus 8, meaning they're positive y-intercepts, but if subtraction is part of the equation, obviously the y-intercept will be negative to show and be consistent with that subtraction. Okay, two examples we're going to look at, and then we're actually going to identify and then graph based on the slope and the y-intercept. So first equation is y equals mx plus b form. So negative 2 is our slope, negative 2, and then positive 3 is our y-intercept. So turning to the graph, we start graphing this line, y equals negative 2x plus 3. You start with the y-intercept, which is positive 3. To get the next point, we take the slope, which as a fraction is negative 2 over 1. The negative 2 means we're going to go down 1, down 2. The positive 1 means we're going to go to the right 1, and our second point is going to be right here at the coordinates 1, 1. And now we're going to use this slope repeatedly. We're going to go down 1, down 2, to the right 1 to get our third point. Down 2, right 1 to get another point. And as far as we can go before we hit the edge of the graph, we're going to keep plotting points, and this will be the last point that I can get to, going down 2 and right 1. Likewise, if we go back to our y-intercept, we can also go up 2 and left 1, and you'll see that that point is going to fit the pattern. Up 2 and left 1, that point will fit our pattern. And now we've got our equation, y equals negative 2x plus 3. We've got the graph of the line based on the y-intercept and the slope. Second example here, our slope is a negative fraction, negative 1/2. Our y-intercept is a positive 2. So let's start with that y-intercept, positive 2. Always start with that y-intercept. And then use our fraction for our slope. This time it's a negative 1 and to the right 2. So down 1 and to the right 2. Down 1 and to the right 2. Keep going until you hit the edge of the graph. If we go down and to the right, it's the same as going up and to the left. Up 1, left 2. Up 1, left 2. And again, follow that pattern until you hit the edge of your graph. By plotting so many points, that gives the indication of where the line should go. If you've got a straight edge or a ruler, it would be best to use that to get a nice clean line through all of those points. But that's how you take your equation, identify your slope, identify your y-intercepts, and then use those two pieces of information to get the graph of the equation.